Hello, everybody. Today we're going to talk about rational numbers. We're going to answer the following questions. What is a rational number, and how do I compare them? So let's jump right in. Rational number. The definition of a rational number is any number that can be expressed as a ratio. You might see the word ratio right there if you look at just the first 5 letters of rational. It's hiding in the word right there. And a ratio is basically a fraction. So anything that you could write as a fraction is a rational number. Notice I didn't say just fractions are rational numbers, but anything that could be written as a fraction. Because there's some things that may not be written as a fraction, but you could turn them into a fraction. Now, how to do that is something we're going to be going over later on in this unit. So a rational number might be a fraction already, right? Obviously, a fraction can be written as a fraction because it already is. It might be a decimal. Okay, there's a way to turn decimals into fractions that are equal. And we'll talk about how to do that later on. Same with percents. They might be written as a percent. You can always turn a percent into a fraction as well. Whole numbers, they might be whole numbers, or they might be mixed numbers. Remember, mixed number is a whole number along with a fraction. So like 3.5 would be an example of a mixed number. Okay, so all of these are rational numbers. Okay, believe it or not, there are some numbers that don't fall into either of these categories that we call irrational numbers. You're not going to really do much with that this year, but you'll probably learn more about those next year. All right, so how do we compare rational numbers? Well, if we want to compare them, we might be able to estimate depending on what those numbers are, and we'll look at that first. But a lot of times, in order to compare rational numbers, they need to be written the same way. And this is why in this unit, we're going to talk a lot about changing from one form to another. So turning a fraction into a decimal or vice versa. Okay? So that is coming up. Let's start just by looking at a number line and using some of our estimating skills. So I've got 5 numbers here, 5 numbers over here, that we're going to try to locate on this number line. Okay, all these fractions are less than 1. So we just got the number line from 0 to 1. Okay, and right in the middle, I put this 1/2. Okay, a lot of times that's kind of the first question to ask yourself when you're trying to figure out about where a number would be on the number line. If it's not a whole number exactly, you can think, is it more than half or is it less than half? So let's do that with these. So if I had 1/3, well, if I had $3, if there were $3 I was splitting with somebody and I got one of those dollars, am I getting more or less than half? Okay, I'm getting less, right? The other person is getting 2 of the 3. I only have 1 of the 3. Okay, so 1/3 is less than 1/2. So when I'm putting on the number line, it's going to be to the left before 1/2. Okay, so I'm going to put that up here. Let's just go through these first and decide which side of 1/2 they'll be on. Then I'll estimate it a little more specifically. Okay. The next number is 9/10. So if there's $10 and I get 9 of them, well, I'm getting more of my share. So 9 out of 10 is definitely more than half. Okay. 3 out of 4. Okay. Well, half of 4 is 2. So 2/4 would be a half. 3/4 is more than that. So that is more than a half. 5/8. Okay. Again, half of 8 would be 4. So that tells me 4/8 would be half. If there were $8 I was splitting with somebody, if I got exactly half the money, that would be 4. All right, if I get 5 instead, that's more than half. So that's going to be over on the right side. And the last one is 9/20. Okay, so if there's $20, I get 9. I got a little bit less than half. All right, half of 20 would be 10. So 10/20 is half. 9 is less than that. Okay, so I got 2 numbers less than a half, 3 numbers above. Let's try to be a little more specific with where these go. So 1/3, if I want to know where to put 1/3, what I'm going to picture is I'm going to picture taking this number line from 0 to 1 and break it up into 3 equal pieces. If I do that, I might have like a line here and like a line here or something. So this would be the first half. Let me highlight this a little bit. Okay, so maybe this is about the first third. Okay, it's not perfect. I'm just estimating. That's about another third of it. and that's about another third of it. So those are roughly the same. Okay, so if I want to do 1/3, I'm going to put it right after one of those sections. So right there. So I'm about 1/3 of the way. Okay. Let's see, get rid of those guys. Okay, for 9/10, I'm going to think of making a lot smaller marks. So I'm going to think about taking the space and breaking up into 10 equal pieces. So I have a lot more lines in here. Okay, so I think about breaking those into 10. I'm going to put B at the ninth line out of 10. So B would be right about there, right? Okay, so like about the last line would be here. This is the last 10th of this distance. Okay, so that's about 9 out of 10. For 3 out of 4, well, this isn't too hard to imagine breaking into fourths. Right? I already have it, this line breaking into half. Well, if I cut each half in half, then I have 4 equal pieces. So the 3/4 would be 1/4, 2/4, 3/4 would be right here halfway between 1/2 and 1. So I will put a dot right there about halfway between, and that's my C. For 5/8, I want to think about breaking up into 8 equal sections. Well, I said 1/2 was 4, half of 8 is 4, so 4/8 would be right here. 5/8 would just be one more section over, something maybe like that. Okay, the last one, 9/20. Well, half of 20 would be 10. I have 9 instead of 10, so I'm close. I'm just a little bit before 1/2. Okay, so my numbers would be somewhere around there. All right. All right, I'm going to show you 5 more numbers. And I'm going to have you go ahead and pause the video here and see if you can place those where you think they should go. All right, we're back. So let's see where you put yours. So 3/8, is that more or less than half? Well, half of 8 is 4. So 4/8 would be half. 3/8 is before that. So I'm going to put it right about there. All right, so I think about breaking this up into 8 equal sections. There'd be 4 on each side. So 3 out of the 4 of those sections would be 3/8. Okay. 1/5. Okay, well, 1 is definitely less than half of 5. Okay, there. So again, I'm going to think of breaking this up into 5 equal sections, and it'll be somewhere around there. Okay, that's about where B would go. For C, oh, we have the wrong one. For C is 1/10. Well, if I broke this up into 10 equal sections, I need twice as many as when I broke it up into 5. Okay, so if this was 1/5 of the way, about halfway there would be about 1/10 of the way, right? So if I drew a line every about this even, maybe that would break it up into 10 pieces, whereas this would break it up into 5. Okay, so that's about 1/10. It's half of 1/5. All right, 8/9. Okay, if I think about bringing this up into ninths, those would be pretty small pieces. And this is 8 of them, so that's definitely more than half. It's all but 1. So it would be on the last line between the 0 and the 1. It could be on the 8th, after 8 out of the 9 sections. It would be right about there. Okay. Last one is 4/12. Well, now if you remember with fractions, if there's a number you can divide the top and the bottom by, you can do that to write an equal simplified fraction. So we think about 4/12, and I think about the numbers 4 and 12. I know that 4 goes evenly into both of those numbers. So what I'm going to do is I'm going to divide the top and bottom by 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. So 4/12 is the same as 1/3. Okay, so again, if I think about breaking this up into 3 sections, 1/3 is less than half. I already did 1/3 over here. Okay, I'm going to put it after about one of the, if I broke this up into 3 equal sections, after about the first one. Go right about there. Okay, so those are good estimates of my numbers. 4 of them were less than half in this case. Only 1 was more than half. Okay. All right, so let's try to use some of what we know to compare these numbers. So a lot of times you're going to be given two numbers and you want to know which one is bigger. Okay, and we're going to go in kind of a weird order here, but I'm going to start with number 3 because I see something useful in number 3. In number 3, I have 2/5 and 4/5. So the nice thing there is the bottom number, the denominator, is the same. Okay, so in both cases, this is being broken up into 5 equal pieces. Here it's also being broken up into 5 equal pieces. So the pieces are the same size. Okay? Here I have 2 out of those 5 pieces. Here I have 4. Well, 4 is obviously more than 2. Right? So 4/5 is more than 2/5. Okay, if the bottom number is already the same, you can just compare the top numbers. Okay, it's pretty easy. For number 1, I'm going to try to use that trick that I just used in terms of more or less than half. So 2/5. Is 2 more or less than half? Well, it's less. Okay. What about 8/11? Is 8 more or less than half of 11? Well, it's more. Right? 8 is most of 11. So if this is more than half and this is less than half, well, that's got to mean this is a bigger number, right? All right, so let's bring it over. So that is 8/11 is bigger than 2/5. Now, when it gets to number 2, that trick doesn't really help me because 2/3 and 3/4 are both more than half. So in order to compare these more specifically, what I need to do is I need to get to the situation I had over here. I need to get those bottom numbers the same. Well, fortunately, that's something that I can do with fractions, is I can rewrite them to change the denominators. You probably remember this back from when you did adding and subtracting fractions. If not, we're going to be looking at that pretty soon, so get ready for it. So to illustrate what we're doing here, let's take this circle here. This circle is cut into fourths, right? Remember, the denominator tells you how many pieces you're cutting your whole into. So if I wanted to represent 3/4 here, what I would do is I would cut my circle into 4 equal pieces, and I would just shade in 3 of them. And so this is 3/4. Okay, coloring outside the lines there a little bit. Maybe we can erase that. All right. All right, good. So that's about 3/4. Now, one thing that we can always do is we can change the number of pieces that we have. And when we do it, it'll change the number of pieces that are shaded as well. So right now this is 3/4. 3 out of my 4 sections are shaded. But what if I decide to cut each one of the pieces in half? So I'm going for smaller pieces. Again, all the pieces need to be the same size. I'm just making them smaller, making them half as big as what they were. All right, when I do that, now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces, right? Because I cut each one in half, I have twice as many pieces. Well, if I look at how many are shaded, well, each one of those pieces also got cut in half. So I doubled the total number of pieces, but I also doubled the number of pieces that are shaded. So instead of having 3 out of 4, now I have 1, 2, 3, 4, 5, 6 out of 8. So 6/8 is the same thing as 3/4. Okay, and notice how with 3/4, if you multiply the top and the bottom both by 2, you would get 6 out of 8. And we can do that by multiplying the top and bottom by anything we want, right? If I multiply the top and bottom by 3, that would mean I take each one of these pieces and cut them into thirds instead of halves, right? If I did that, I'd have 9 out of 12, okay? Because 3 times 3 is 9, 4 times 3 is 12. So we can always multiply whatever we want as long as we do it to the top and bottom. So I'm going to use that idea right here. So if I want these denominators to be the same, here I got a 3, here I got a 4, I can think, what common denominator could I use? Right? And this is where we can use some of that LCM stuff we did last term. Well, what's the lowest common multiple of 3 and 4? Okay. Well, the first number, if I count by 4s, 4 times 2 is 8. That 3 doesn't go into 8. And another 4, I get 12. 3 does go into 12. Right? So 12 is going to be the denominator that I want to use. Okay. So to get 12 on the bottom, what do I have to multiply 3 by? Let's multiply 3 by 4, because 3 times 4 is what gives me 12. Well, if I multiply the bottom by 4, I have to multiply the top by 4. It always has to be the same on top and bottom. So 2 times 4 is 8. Okay, on the right side, to get from 4 to 12, I have to multiply by 3. 4 times 3 is what gives me 12. So if I multiply the bottom by 3, I multiply the top by 3 also, and I end up with 9 out of 12. Okay. Now that the denominators are the same, I can just compare the numerators, right? They're cut into the same size pieces now, but 9 out of 12 is more than 8 out of 12. Okay, so 8/12 is bigger. Or sorry, 9/12 is bigger, or 3/4. Okay. All right, let's do a couple more. So this one, I have a 9 and a 6. If I think about common multiples, let's do the multiples of 9. 6 doesn't go into 9. If I double 9, I get 18. 6 does go into 18. So I can write both of these as something over 18. All right, now for 3/9, to get from 9 to 18, I have to multiply by 2. So if I multiply the top by 2 also, 3 times 2 gives me 6. So 3/9 is the same as 6/18. For 1/6, to get from 6 to 18, I have to multiply by 3. So if I multiply the top by 3, 1 times 3 is 3. Okay, so comparing these, they both have 18 on the bottom. 6/18 is more than 3/18. Yeah. So that tells me 3/9 is more than 1/6. Okay, on this next one, if I count by 9s, I got 9, 18, 27, 36. 4 goes into 36. So 36 is the first common multiple they have. Now you might notice 36 is also what you get when you multiply 4 times 9. If nothing else, you can always multiply those denominators to get a common denominator. Okay, it doesn't need to be the lowest common multiple in this case. It's just kind of nice if it is. Okay, so to get from 4 to 36, I'm multiplying by 9. So 1 times 9 gives me 9. Over here, to get from 9 to 36, I multiply by 4. So 6 times 4 is 24. Okay, well, that's pretty easy to see. 24/36 is more than 9/36. Okay, if you were paying attention, you might also have noticed this one I could have just used the fact that 1/4 is less than half. 6/9 is more than half. So that would save me a little bit of work there. All right, can I use that here? Well, no, these are both more than half. So I got to rewrite them with a common denominator. Okay, if we look at 5 and 8, the lowest number that 5 and 8 both go into is 40, which again you get just by multiplying 5 times 8. So I got 40 on the bottom. To get from 5 to 40, I have to multiply by 8. So 3 times 8 is 24. To get from 8 to 40, I multiply by 5. So 7 times 5 is 35. Okay, so now that the bottoms are the same, 35 is more than 24, which tells me that 7/8 is more than 3/5. All right. So let's just briefly make sure we remember how to compare decimals also. So when you're comparing decimals, you want to do it place by place. So the first thing you want to do is you want to line them up so that the decimal points are on a line, just like we would if we were going to add or subtract them. So let me bring them up here. I'm going to line them up so all the place values are lined up. Okay, so that decimal point is all in the same place. Okay, now that I have them lined up, I'm just going to go from the left to the right, and I'm going to compare the number in each place value. Because with decimals, as soon as you get to the point where one is bigger than the other in a certain place value, that means that number is bigger. So here I have 0, 0, 0, and 8. So I'm going to move 8 out, and I'm going to compare these three. So these three are all tied. So I'll go on to the next place value. So now I'm in the tenths. So for the tenths, I have a 0, an 8, or a 3. Well, The 0 is the smallest of those three. So that means this is going to be overall the smallest number. Okay. Still comparing in this tenths place, 3 is smaller than 8. So that comes before this one. Okay, and this one was the biggest because it was biggest from the beginning when I was comparing this spot before the decimal. So that is the order that they would go in from least to greatest. Let me bring these over here, and I'm going to ask you to pause the video and see if you can figure out what order these should go in. Okay, so we're back. So for looking to organize these from least to greatest, I'm going to start with the very first position. I got them all lined up, so their place values are in order. I have a 4, a 2, and a couple of zeros. Well, the zeros are the smallest, so it's going to be one of these two. These are still tied currently, though. So I'm going to go to the next place value, which is the tenths. 4 and 4, they're still tied. Okay, go on again. 2 and 2, still tied. Go on, here we go. So I got a 3 and a 1. Well, 1 is less than 3. So it doesn't matter what comes after this place. When we get to the first place value where they're different, if this is smaller, that means that's going to be a smaller number no matter what. Okay, and then this would be next. Okay, comparing these two numbers, I can start back over at the very first position. 2 is less than 4, so that's going to be ahead of that one. Okay, so with that in mind, we've looked at some decimals and some fractions. Let's see if we can put some on the number line here that are not necessarily just less than 1. And I got a mix of both decimals and fractions. So let's start with 2.4. Now, when I grade questions like this, I'm going to be looking basically for two things. I'm going to be looking for, do you have it between the right two numbers, and is it closer to the number that it should be closer to? So if I have 2.4, okay, well, the fact that this is 2 point something means it's more than 2, right? But it's less than 3. So it's somewhere between 2 and 3. So it's going to be in here somewhere. Now, as for which one is closer to, 0.4, remember, back to our place value, means 4/10. So is 4/10 more or less than half? Well, half of 10 would be 5. So 5/10 is half. 4/10 is less than that. So this number should be between 2 and 3. It should be a little bit closer to 2 than to 3. Right? If you were to put this on your test and put it closer to the 3, I'd have to take out points for that. Right? You got to know that it's closer to 2 than it is to 3. It would round off to 2 instead of 3 if we're rounding to the nearest whole number. All right, for the next one, 3 and 1/2. Well, it's 3 and 1/2, so it's more than 3, but it's not quite up to 4. Right? It's got 3 and then a little bit extra, but not a whole number extra. So it's between 3 and 4. And if I look at that 1/2, well, it's not more or less than half. It's exactly 1/2. So this is going to go exactly halfway between 3 and 4. Okay, remember for letter C, we got 1.8. So it's 1 point something that's more than 1. It would be less than 2. So it's between 1 and 2. 0.8 again is 8/10. Well, 8 is more than half of 10. So it would be something like that. Again, if I imagine cutting this into 10 equal pieces, 8/10 would be 8 of them on this side and 2 of them on this side. Okay. So that's 1.8. For 1 and 1/10, again, it's between 1 and 2. The fraction part is 1/10. Well, that's a lot less than half. That goes something like that. Right? Again, cutting this into 10 equal pieces, that's after just one of them. All right, last one is 3 and 2/3. So 3 and 2/3, it's 3 and more. So it's more than 3, but less than 4. Okay, for the 2/3 part, well, 2 out of 3 is more than half. So again, I imagine cutting this into 3 equal pieces and putting this after 2 of them. And our numbers would look something like this. All right, so I got a few numbers for you to do. Again, I will pause the video. Please draw a number line like this from 1 to 5 and see if you can place these where they go. And then we'll make sure we got the same thing. Okay, we're back. So hopefully you got numbers that look something like this. 4 and 1/4, it's between 4 and 5, closer to 4. 3.6 is between 3 and 4, just a little closer to 6, or a little closer to 4. Remember, 0.6 is 6/10, which is just a little more than half. 4 and 8 ninths is between 4 and 5, closer to 5. 2.2 between 2 and 3, closer to 2. And 2.6 still between 2 and 3. But 6 tenths is just more than half, so it's a little closer to 3 than 2. Okay, that's all I got for you today. Good luck.